Welcome back to PASC 2024 and our sharing of highlights from the conference Minisymposium. Joining me here on stage, I have Sinead Ryan and Marina Marinkovic, who have organized a Minisymposium on Lattice QCD and quantum computers. That sounds so like state of the art. First, the background here. I need a refresher. I have a theoretical physics PhD, but it's like 25 years old. What is Lattice QCD and why do we need computers for it?
So Lattice QCD, is short for lattice quantum chromodynamics, which is a theory which binds quarks and gluons to form hadrons, such as protons and neutrons. And it's very hard to study this theory analytically with pen and paper because it's strongly interacting. So one cannot neglect interaction and then turn it on piece by piece, what we usually do in theoretical physics. This is called perturbation theory. But we need to discretize four-dimensional space-time in order to get predictions from this theory and to compare them with experiments such as Large Hadron Collider at CERN and also other particle physics experiments around the world. So this is why we need high-performance computing to obtain predictions from this theory.
So that sounds like a very worthwhile course to advance fundamental physics understanding, right, and everything. So where do the quantum computers enter into this? Because that's a different quantum, right?
Absolutely. It's a really interesting question because we've done huge amounts in the last 40 years with classical computing, so as Marina said, but there are still some problems that we just can't attack with the traditional classical methods that we have, even with all of the technology advances and bigger computers running at exascale. So there are some aspects of QCD where we really would like to be able to do calculations. So real-time dynamics is one, and understanding what happens as you increase the density of systems. So that takes you, if you want to think about to understand the core of a neutron star, for example. So there in those very dense environments, our traditional Markov chain Monte Carlo methods just don't work in the theory.
So what did you learn at this Minisymposium? Are we closer to the solution?
Yeah, we're definitely closer. So it's really exciting. We're not doing QCD yet on quantum computers, but lots of really exciting new ideas are emerging in lower dimensional models and different simpler models for quantum computing. So we're learning a lot.
So what's the main challenge? Is it related to developing the algorithms, or that the quantum computers aren't, well, hardly exist yet? We have a few qubits.
I think it's really similar to the initial part of high-performance computing. So we now have a chance, together with experimentalists and together with computer scientists, to create this field to be performant or as performant as possible from the start. So similarly as designing chips for high-performance computing, here we have a chance to take the most from all technologies which are available currently and try to get as optimal as possible in simulating, as Sinead already mentioned, lower dimensional systems before building up over the next maybe decades to get to QCD.
So based on this Minisymposium then, was there any particular highlight, something that is going to cause you to start working on things next week?
I think so, actually. So there were really some ideas that I wasn't aware of, how things like quantum link formulations had really advanced and we have much better understanding of how they work. So I'm really excited about it, actually, thinking about what I might do when I go home.
Cool. So how long will it take before you're actually running your simulations on a quantum computer? Do you have any gut feeling?
We actually already, many of the participants of the Minisymposium and also Trinity College and at ETH, we are already running small-size simulations on quantum computers, but it's going to take several years already to scale it up.
So while we're on the algorithmic level, you're then ahead of the hardware industry. You're just waiting for more qubits then.
But you know what lattice people are like, Eric. I mean, they take every opportunity they can get.
The second either the computer is empty or it's full.
Exactly.
That's a good summary of your needs. Thank you so much for joining us, and thank you for listening.
Thank you.